Namaste and welcome to this exciting new episode of Sattology, debunking mythology. Sat means truth, logos means study or science. Sattology means science of truth or study of truth, just like biology means study of biodiversity or science of biodiversity. Opposite of Sattology is mythology, which means a study or science of fake. Can you ever thought that how can there be a science of fake lie or imagination? Is it scientific? Yes. If you present mythology as a science, it is fakery. Anyway, and the Western academics generally have coined this term generally for the Vedic culture, but later on it started being used for every single native. And believe me, we are doing a lot of work with Native Americans, for Native Americans in West Virginia, Pennsylvania, Oklahoma, and California. These are the largest populations of Native Americans in the USA. In South America, we are planning to begin work in Brazil, Chile, Bolivia, and Argentina. If you would like to join, you are free to join us and just come travel with us. That's it. And today we are doing a very, it's going to be a wonderful show, one of the best shows that we have recorded. When the Western world was in their pajamas on astronomy, then the Indian sadhus, rishis, munis were wearing a three-piece suit. You can say that's how civilized they were. And I have a great rishi, muni, researcher, scholar par excellence, and a fantastic, humble individual joining us today. Without delay, let us welcome Sri Nilesh Oak.
Namaskar Aditya ji, and always happy to be here. I like the PJ and the three-piece suit. By the way, for those who may not be aware, the PJ, or the pajama, that came from India too, by the way. Okay, that's even the way the name goes. And of course, not the direct suit, but the textile, which was used eventually to make all different things, right from silk to cotton, and the domestication of it is a gift of India. Now, in case of silk, also China and the broader area, like Burma and the Myanmar and Laos and Cambodia. And in case of cotton, very much India. Like we go all the way back to the time of Rigveda. Older portions of Rigveda. So we are talking thousands and thousands of years. Gruhatsmat. By the way, I know your family had a connection not only with the southern part of Maharashtra, but Yavatmala. I remember you mentioning Yavatmala once. Mm-hmm. And it is a bit of a conjecture because we are talking 50,000 plus years. But I have read it multiple times from different people that it is conjectured that Gruhatsmat, who was a winker, who knew how to weave things. It's said that he belonged to Yavatmal. Something very interesting, and then some close connection that you had, which is with the textile mills. So very interesting.
No, my father was a gold medalist from IIT Delhi in textile engineering. And he founded a textile factory, and he was known as a weaving master of Maharashtra. Mm. So it runs in my blood, and all my fabric that I have in all my suits are made in India, cloth. And Turkish, most of the time Turkish carpets are made in India. Mm. And Egyptian cotton, which is a Western myth, has been spoken. The Egyptian cotton is very soft, but it's not durable because you cannot wash in the washing machines. So Indian cotton is the best. And I would request the Indian Agriculture Ministry or anyone else who's watching the show today that do not use BT cotton because the GMO crops have been introduced in cotton to destroy Indian cotton industry. So do not use that and try to preserve the older versions of cotton, which are organic in India. Now, coming back to the astronomy, which was our topic. And so I was so fascinated, like when I am searching for Abhijit and Vega, like you only told me. And after that, I did buy a telescope to watch them. And is there a list available where which stars, or you have compiled any list, or you would like to share something to educate people that which star in the Western world Canopus is and what is this? If you can share that, that'll be fantastic for Indian viewers.
Okay. So there is a list of stars. I mean, there are star catalogs that are being published with their specific positions. With the modern software, it makes it even easier. In fact, you can download a software. For example, there are many softwares. If you want to, the old term for good cars, no longer true, or no longer, people may not even recognize it. I don't know what's considered the latest and coolest car. Well, we'll say Tesla, for example, but the old times, if you remember, they will say Cadillac, Cadillac of something. That was the term that was used. So if I have to still use the old term and say Cadillac of astronomy software or Tesla of astronomy software, there is a Carina soft. There is no particular bias or anything. I mean, it's a proof is in the pudding. Anyone can take a Carina software. It's beautiful, and actually people should be expert in the sense, instead of leaving everything to the software, they should understand the astronomy map, approximately point their telescope there, and then for fine tuning they can use the software. Mm-hmm. It's more fun to actually recognize the stars, which stars they are, and you pointing it yourself. But software can also help you. Once you put the coordinates of your location and the timing, the clock, the software knows which star should be seen where. And if you just tell the command, like, please point my telescope towards that star, actually it will do it. But because it has to go through too much of the mechanical movement, it's good idea for you to know the approximate one and locate. So in software also, you get a very decent idea. Like, you click on one star, it will open up like information boxes and give you a lot. There are astronomy catalogs that are published, but your question could be possibly, you didn't ask explicitly, is like the how do we recognize with the name? For example, is name Abhijit given to a star in a modern software? Yes and no. Sometimes it is, depending on some of the options. Other times it is not. But many softwares allow you to customize it, and that's how I use it. For example, the stars, the Western star catalog names, I can go and change the star name to what I want. For example, I do that for all 27 nakshatras. I will do that for Abhijit, and therefore same as a Brahma Rashi, the Canopus as a Agastya. So Vega becomes Abhijit or Brahma Rashi in the application I use. And the sky is the limit. I mean, they are all in the sky, and how much you want to know is really the limit up to you. What happens is, many people, when they think of astronomy, actually, you mentioned Dune School. Now, we didn't have a plan, but now that you mentioned a Dune School, I will say something. I am working with a instructor at Dune School to create the astronomy syllabus, astronomy textbook, you can say, or astronomy course material that will be used. How far the Dune School went? Up to 12th grade? I mean, I don't know, or 10th grade, or whatever that thing is. Yeah. For all those years, whenever they're teaching astronomy, we are trying to design the course. The reason I mention that is, most of the astronomy courses, I mean, I have seen the courses at MIT, Harvard, Yale, everywhere in America. They will talk about the basic solar system, and then immediately they get into what is the constituents of each star, like what metals is there and so on. And that has its own utility. But that is not, I don't think that's how astronomy should be taught. Many times students take it because it's one of the elective that they have to take. But I truly feel the way I'm envisioning it, and I'm going to discuss with him. In fact, he asked me like a month ago, and I haven't found the time to do it. I'm going to do it. I want to do it in such a way, the way we have discussed some of the history, like for the Western world, starting with Ptolemy, the whole 1500 years and nothing happened. And then the Copernicus comes on the scene, and then the church wants to prosecute. I mean, church doesn't like it. Even Copernicus is so scared. He doesn't want to publish his books until he's ready to die. He says, please publish it after I'm dead. I mean, just think of, how much of a dogma is there. I think I'm convinced that it needs to be taught, not so much the religion science confusion in the West. It's still there. But when it is taught in the sense of it's being useful, people will appreciate it more. Like just tell somebody, like this Viking serial, just tell somebody, if you want to go on the ocean and if you don't have a knowledge of astronomy or a direction, how challenging, how daring, and how scary is that voyage. So the astronomy, when they start seeing the beauty, the utility of astronomy, like say for sea voyages, then they start appreciating not only astronomy but the advancement, the three-piece suit metaphor of Indian astronomers and how far they have gone. Just I'll stop this my monologue by saying that the position of Canopus or Agastya, star Agastya in the Indian astronomy, and it attaining a latitude of 80 degrees is mentioned in Surya Siddhanta. Now, why is this great? Why is this important? Because the last time, starting from today, if you go backwards, the last time Agastya star had attained the latitude of 80 degrees was in 38,000 BCE. 38,000 BCE. We are talking 40,000 years ago. And they're talking the latitude of it. So it's not like a 38,000 BC and somehow people were just looking at the stars. No, they had this whole astronomy thing mapped out. Okay, so it is that ancient. And today, we are not going to divide in the sense of Indian astronomy versus Western astronomy, but definitely want to talk about the foundations of astronomy and how that is used to understand our past.
So one of the things which come to my mind is, was it a colonial era conspiracy also to rename the Indian names into Western names? Because most of them are, and actually generally they just put the, other than Vega star, other than that, which is Abhijit, right? Abhijit. Other than that also I learned from you. But do you think that is a conspiracy also? Or there is a ploy to again build the Abrahamic thought process in the astronomy also?
Okay. Well, I don't think there was a conspiracy. In fact, if you look at astronomy as a subject, I would say whether the Western Europe liked it or not, because they were driven by their life, because to go on a sea voyages, which is what they were interested in doing for their survival, for their sustenance, and of course, eventually prosperity. But they did not have the science of astronomy with them. So in a way, it was like unknowingly, it was the Indianization of a Europe, through the astronomy. I don't think they changed the names. Now, what happened is the names came to them through the text which were written by Arabs. Now, Arabs readily accept the contribution of India to their astronomy knowledge. In the Arabic world, at night you get to see the stars very well, and in fact that is the pleasant time. The weather is not very hot, and the celebrations and parties would be at night. So they were in a close touch with the stars. So they made many good observations, the Arabs, and through Cordoba, the parts of Spain, the astronomy reached Europe. And therefore, the names are many times Arabic in origin. In fact, Betelgeuse and Al-Nitak, Al-Nilam, Al-Dabaran, these are all the Arabic prefix, right? So these are all Arabic names. And I don't think there was a conspiracy. At least I don't think so. What if, I don't want to call it a conspiracy, but what happened was, even when possibly likes of Copernicus and others, or even Kepler, even Newton, even when they knew the original sources of astronomy, which they popularized with their own discoveries, own contributions in Europe, I don't know why they never acknowledge the origins. But there could be two reasons. One is that they wanted to show their popularity, but another one is if they would have shown that the origins of that astronomy are non-Christian in origin, then they would not have been easily accepted by the masses and especially the church. So therefore, they might have hidden the original sources. So that's what I think, but I don't think it's a conspiracy. The names were Arabic in origin for the most part. And in a relatively recent phenomenon is the very standard astronomy, like so post-Newton, a lot of observations were made beginning with Galileo, and all the stars were documented, and they were given the names based on many of the names are Greek in origin. Therefore, you say alpha, beta, gamma, and then the particular what you call constellation name. And that is because the Western Europeans, they didn't care for science for a very long time. But finally, once they sort of matured into the Renaissance period, then they were in search of finding the roots for their civilization. And they couldn't admit that these were East Asia, like China and India and other places, or Egypt or South America, like Mayan astronomy. So they settled with claiming it to be their origins, and therefore the world's origin, which is a nonsense, but the origins of their science in Greece, or among the Romans. So that's their, I mean, sort of agenda-driven, something that makes them comfortable type of history writing. But what we will talk today is we will get into foundations of not so much of politics of astronomy, but the foundations of it. So Aditya, I mean, if you want, I can start sharing, unless you want to discuss something else before I start sharing.
Yeah, please start sharing. Yes.
Okay, so I'll do that. So quick one again, we have discussed many times, the astronomy sort of remains the fundamental or theme when I discuss things. The foundation of astronomy is very important that we understand, and it's not complicated. It is a one simple phenomenon that leads to many different symptoms, many different outcomes. And when they are employed, they are used by the historians, by the narrators around the world, we can use that knowledge using these foundations of archaeoastronomy to date those events. Now, this we can do everywhere. We can do this with Stonehenge circles in United Kingdom. We can do this with the pyramids in Egypt. We can do with structures in Peru. I mean, we may not always be successful, but like Aditya mentioned, traveling with Zeb Hamisinji, to Peru. So we have the Nazca lines. Can we make sense out of it? The orientation of Machu Picchu. Okay, there is a Huayna Picchu. There is a lot more structures. There are places in Bolivia. There are places in Amazon jungle that is actually not been found yet. I mean, not been explored properly. As I said, Egypt, there are structures in Africa. There are structures in Europe. There are structures in the eastern part of Russia, China, whole of Asia, like Indonesia, and of course, India. India also is especially blessed. And there are a few other places like Egypt, for example, and Latin America, where you have very rich astronomy descriptions in the narratives, which is not true for most of the other world. So it's really doubly rewarded, and you can do it. But important thing is that we understand the foundation. For example, just as a metaphor, how do we compare this? Like, what exactly are we talking when we're talking the foundations? Think just as a metaphor, imagine a combination lock, a master lock, okay, combination. And if we go back all the way to the cosmology origin, like say Big Bang, okay, so that's 13 billion, 14 billion years ago. Come fast forward to the formation of the sun, our star of the solar system, whatever that time is. Let's fast forward or almost the same time contemporaneous with say Earth, and imagine the Earth, we take it to be 4.5 billion year old, okay? Not a livable Earth, but just a piece of mass, and maybe a molten mass, maybe hot, not very suitable for living. But if we would do that, that understanding is required to understand where astronomy fits in, okay? So for example, if I start with the Big Bang, okay, then if you want to date something in that 14 billion years, or if you want to go to multi-universe before the Big Bang, like question we ask, what was there before Big Bang? And now they're talking about multi-universes. So there were universe before, it came into a singularity and another universe began. And we just happen to know this one universe, 14 billion year old. And that's all now we have figured out, going backwards. But so there could be universes before, but if we cannot get the data, we cannot talk about them. They may exist, they may not exist, but no way to do it. So my point is, in terms of the infiniteness of the existing universe or the universes before, or if there are other universes, the combinations essentially are infinite, okay? But unless we have a way to track this, we cannot do anything. So let's make the problem a simple one, something manageable for our solar system or for the Earth. So we might say, well, let's talk about only last 4.5 billion years. Now, 4.5 billion years is a very long time. Fortunately, and I'm going to get now specific to Indian astronomy for a minute, but that is true for all the other world astronomies that we are aware of. In fact, Indian astronomy is the oldest that it can at least indirectly talk of something like this. So we are talking about a upper limit of 200,000 years or 2 lakhs years, the Indian number lakhs. How do I get to this number? Because the astronomy, especially the 27 nakshatra system, that we are discussing, if you go beyond these 200,000 years, we cannot use the existing nakshatra system. And that is such a nice thing in the way that it gives us upper limit. So using astronomy, how far back we can go? Now think of a carbon dating. Carbon dating tells us that we can go up to 50,000 years. Okay, thermoluminescence can possibly go to million years. And so we have different techniques that can take us to a certain limit. Okay, and after that, the technique does not work. We have to find another technique. In that sense, the astronomy, at least the core Indian astronomy made out of 27 nakshatra system that you find in Rigveda, that you find in Ramayana, that you find in Mahabharata, in Puranas, in all the Indian astronomy Siddhanta texts, that has an upper limit of 200,000, maybe 250,000, but honestly 200,000 will do for our practical discussion. So anything before that, if we are trying to date it like in a historical sense, astronomy will be of not use. I mean, astronomy is extremely powerful. In fact, one of the best technique, not one of the best technique. I don't think it's one of the best techniques. In knowing the ancient history, the precise and accurate way, if the evidence exists, but it has its limits. Beyond 200,000, possibly 250,000, 300,000, it reaches its limit. In some sense, it can be extended, but we'll not talk about that today. Okay, now let's come closer. Now we have so now imagine that we are master lock. We are going, the first round is like infinite, just not even have it here. What's the point? Okay, because we are not going to select anything. The second 4.5 billion years, that's too far back, in terms of livable life and history and civilization. So more than likely, I'm going to say the number 3 can be our first line there, first combination. Okay, so 200,000 years. And where are we in that 200,000 years? Then if you go to the fourth combination, so here I would call second combinations on the log, it has a cyclicity of 26,000 years. That is the precession of the Earth's axis. And that is one of the fundamental aspect of archaeoastronomy. Everyone must understand it. Then we can talk about a time interval cycle of 5,000 years. And I'll explain what that is. Okay, that is the shift of a lunar month with respect to season. Okay, and how much is that shift? Shift of a 1 month with respect to the season every 2,000 years. And in the Indian context, there are 6 seasons defined. Each season is of 2 months. So we are talking 2,000 and 2,000. So shift of one particular lunar month through the whole season is like a 4,000 years. And if you understand the concept of an intercalary month or Adhika Masa, then you can add another 1,000 years. And therefore I said there's another combination that you can use, which is a combination time interval of 5,000 years. Okay. Now do realize that this is very, very crude at a very high level. These are called long-term changes. Okay. The phenomenon due to long-term changes like precession of the Earth's axis. That's why it is happening, or the proper motions. But do recognize there are n plus combinations. Okay. And that all depends on what evidence is available. How many different combinations are possible, what strategy we need to use, it cannot be decided a priori. We have to first look at the evidence to decide what strategy we will use. We have to define what is my objective. Okay, what problem I'm going to solve. I have to first propose a theory to solve that problem. Then that theory is going to tell me what evidence I'm going to look at. And then that evidence is going to tell me what are the different types of combinations I'm looking at. Okay, so there are multiple combinations, they are not known. Okay, now what I'll say is look at this picture. Everyone has used the master combination, the combination lock, right? At your lockers in gym and whatnot. Well, combination lock is a linear combination. Like, you might have a combination such as word 3, that's your keyword. Archaeoastronomy is not a linear science in that sense. It's not complicated, but you have to put some initial investment, a lot more than understanding how to use a master lock or a combination lock. And it is multiple orders of magnitude complex than just simply solving a two-dimensional jigsaw puzzle or a crossword puzzle or even a Rubik's cube. Okay, so it is actually multiple levels of complexity than a simple jigsaw puzzle or a crossword puzzle. Now, this is very important because most novice researchers just make a mess out of it. What is this point? Outcome of archaeoastronomy, it stands on its own merit. Okay, if the sufficient data exists, if you take over a real problem, and real meaning a practical problem, and if you're lucky that you can solve it because the evidence exists, the outcome stand on its own. I mean, that outcome is better than evidence coming from any other disciplines of sciences. Okay. However, a good thing is the outcome of archaeoastronomy, it can be, we may be lucky and it can be validated with evidence from other disciplines of sciences like geology, which is what I've done. So I've listed this. There could be many other sciences that I have not listed because that's not my experience. I didn't come across them, but that's not to deny them. Geology, evolution, climatology, oceanography, physical anthropology, paleobotany, paleohydrology, genetics, physical anthropology, ancient narrative genetics. I wrote genetics twice, oceanography, paleontology, archaeology. The list that I read, I have used evidence from each of these in supporting, in corroborating my dates for Ramayana, Mahabharata, and Rigveda. Okay, so I'll show you a quick list of the precession of the Earth's axis, and actually I'll go to a simulation. Okay, so Earth's axis is inclined with respect to the ecliptic. The ecliptic is the sun's path around the sun. The point where Earth axis points to in the northern hemisphere is North Celestial Point. Just stay with me. I'm going to walk you through a visual simulation of this. That's called North Celestial Point. If there is a bright star in the vicinity of NCP, it is called the North Pole Star. Same thing happens on the south side. Earth's axis moves through a slow gyratory motion and completes one cycle in about 26,000 years. And this is the precession of the Earth's axis. Okay, so I'm going to stop this and I'm going to start another simulation. And let me see if I can find it. So let's see. Here, axial precession. And where are we? Okay. Yeah, there we go. Okay, so Aditya, you can see this on the screen. Yes. I don't want to be like me talking without showing you the screen.
Yes, we can see the screen.
You can see the screen. Yes. Okay. All right. So what I just talked, I mean, sometimes it can sound very boring, but actually if you start watching the sky, and thank you, Aditya, for investing into that telescope. But some of these things, I mean, you don't need a telescope. So what we have here, see, this is Earth at the center because we are watching from the Earth. The sun is we can imagine going around the earth, that is through the year. So sun completing one cycle. These are the cardinal points. For simplicity, we can think of this as a 21st, day 21st in the calendar of a June, of September, of December, and of March. Those are the spring equinox, summer solstice, fall equinox or autumnal equinox, and a day of winter solstice. Now we are going to start simulating going back 26,000 years, because remember, it's a cycle of 26,000 years. What's happening is, this is what I mean. As Earth's axis is inclined, that's why I'm showing this line, NCP, SCP line inclined, with respect to this path or the plane of the sun's motion as seen from the Earth. Okay. And this is at incline in the sky up there. And as I go through this 26,000 years, you will see what happens. In fact, notice what is happening here. And also notice, this is this circle here is essentially my circle in the northern sky. These are the North Pole polar region. This is the southern polar region. Just quickly to tell you, Aditya, because we did discuss today, this star here, if you can see my pointer or cursor, it is the Abhijit or Vega or Brahmarashi in the northern hemisphere, which will be a pole star again in 14,000 CE. It was a pole star in 12,000 BCE, that is at the time of Ramayana. Now think of it, that is the exactly time when Canopus, the Agastya that I told you today, the latitude of 80 that it attained in 38,000 BCE, that was also a pole star at the Ramayana times 12,000 BCE. So let me run this and see what you see. Okay, so that is what we mean by the precession of the Earth's axis. The important phenomenon, the foundation phenomenon, the foundation for the entire discipline of astronomy, but also the entire discipline of archaeoastronomy. That is to say, use the astronomy evidence to determine the date of ancient events. Okay, so that's what it is.
So Nilesh, just one question: is what is the name of this software, if people want to?
Okay, so this is actually it's not, I mean, it's not a software, it's called Geo something, and the people can create this. Our good friend Amresh GS, he creates this for us. Like he has created it, and both Rupa ji and Rupa Bhatti ji and myself we are using it. So he's a fascinating individual. So this is actually, Aditya ji, not astronomy software. This is actually the geometry software, and so we create a simulations through it. Okay, so because what happens is, and sometime I'll share astronomy software too, but they are very precise and accurate. The problem is they will not have these views. So somebody has to be an expert to use those software, So, but for visual purposes, so imagine all these 27 nakshatras here or these cones. None of this will be available there, but they will have pictures like these, But then it's left to you to figure it out what's happening. Okay. So, for example, I'm going to reset this and do it again. So we are going to go start 26,000 years. And so what did you notice? The Earth's axis, where it's pointing to, that changes. We also see another thing, which is what? The cardinal points, their reference with respect to the background nakshatra also changes. These are the symptoms or the outcomes of this very fundamental phenomenon of the precession of the Earth's axis, which is I would call them woke Indic researchers. They think this is something proposed by someone like me or Dr. Vartak or Lokmanya Tilak. I mean, I would love to take the credit, but it's not my invention. It is happening for 4.5 billion years or whatever that is. We just noticed it. Indian astronomy talks about the speed at which does it, like a 54 arc second. Very fascinating. Okay, so I'm going to run this again. So you see what is happening. The Earth's axis, where it is pointing in the sky, that is that NCP and SCP is changing. And notice whatever is that, where the arrow is going, that is where closest star to that, this pink and green point that is moving will be considered a pole star during that time, like plus minus 1,000 years. Okay. So with that, we will almost complete this. We came all the way to 2100 BC. Okay. So So this is one. Now I want to show you something else. Now, Aditya, tell me if you see it. If not, then I have to disconnect and come back again. What do you see right now on the screen?
I see the same GeoGebra.
But do you see here 12,240 BC or no?
That's right. I see that.
You do see it. Yeah.
Yes. Yes.
Yeah. And so that is the answer. You asked me like, what is this software called? GeoGebra. It has a mathematical calculator, a visual, a geometry type of software. And thanks to Amaresh ji, because he creates this for us, and it's very easy to see. You can see it's a visually very nice. You can show all these nakshatra in a simpler form. You can also show the inclination of the Earth's axis. You can show the positions of the cardinal points. And actually, I'm going to show you a few things here. Okay, so just give me a second. Yeah, all right. So, for example, if I remove the season, so you can see how clean it can get. Let's see. And so we have a nakshatra space in the background. We are still talking the fundamentals of it, right? So one thing that we did is we said the precision of the Earth's axis take 26,000 years. The phenomenon that we saw is because of that, the NCP and SCP, they change. And when the NCP changes, a bright star next to NCP is considered a pole star. And therefore, pole star changes through these 26,000 years. And for example, the Brahma Rashi or Abhijit or Vega means the same thing. That was a pole star at the Ramayana times 12,000 BC. It will be pole star again in 12,000 years from today, like 14,000 CE. Okay, so it goes through the cycle. And right now, Polaris is our pole star. Again, 26,000 years from today, it will be a pole star. Okay, so that's what is happening. Here we are going to see the effect of this precession on the lunar month of our Indian calendar. And why is this important to understand? Again, I would say the woke Indic researchers don't get it, but let's forget about them. I don't think they're ever going to get it, or it may be a lucky coincidence. Majority of even well-meaning, forget about those who are interested in the Jalpa and Vitanda, but majority of Indians, I would say, even the well-meaning Indians who really truly want to know, they find this complicated. And I don't think it's complicated, but watching more Bollywood movies is not going to help. Okay. Like, you have to develop some certain interest in something, spend some time, just me and Aditya ji talking will get you inspired, but you have to do some tapasya. You have to invest certain time to understand this. And I don't think it takes that long. It depends on how serious you are. So I'll show you how the beautiful the Indian lunisolar system works. So we have Earth at the center. This is the blue line. The blue circle is the path of the sun. And therefore, we have marked the vernal equinox, the summer solstice, fall equinox or autumnal equinox, and winter solstice. Okay, this is my background nakshatra. What I'm going to do is just activate the moon. Okay. And I'm going to let it go. Now, by the way, this timing is the birth year of Rama, but we can ignore that. I mean, that's not the relevant today. But I will also show you what is the significance of it, 12,240 BC. But let the moon rotate. Okay. The moon is going around the earth as we see. It goes around the earth and completes one circle from one nakshatra to another. So for example, if I just stop it. So let's say that it is at nakshatra Ardra. So if I want to go there and stop at Ardra Nakshatra again, from one nakshatra, the same nakshatra to same nakshatra, it takes about 27 days. Okay. That we can call it like a sidereal lunar month. Okay. Because it's reference to the nakshatra, with a star. Then there is another one that we will talk about, which is to say what? From the same phase of the moon, Amavasya to Amavasya, full moon to full moon. And we call that what? Basically another type of month, right? The typical civic month or synodic month of lunar month. Now, for that, we need to understand the reference point of the sun. But before I do that, so this may sound complicated, but think it this way. Earth is where it is, at least although Earth is rotating, it doesn't feel like it to us. Earth is at the center, moon is going around it. We are not taking into account the sun right now. Imagine, so nakshatra system is fixed. Okay, for one lifetime, for 1,000 years, not much change is going to happen. Okay, it may move because of the precession, that we will do that in a minute. But the moon is just going around, and the connection of a moon in a specific nakshatra, it's same. This is just going on. What you are seeing on the screen is just going on. Now I'm going to stop it, and I'm going to introduce the sun. Okay, and I'll also reset it. So just imagine this is the day of a 21st of March, the vernal equinox day. And it so happens that every year it won't be true, but moon and sun are together. This is what we call the new moon day, the Amavasya. Okay, new moon day or no moon day, because you cannot see the moon from the earth because it's right where the sun is. Okay, if they are in alignment, we will have an eclipse. Okay, we will in fact have a solar eclipse, but not every time. So now what happens is, for the lunar month, for the Indian lunar month, we need to know the position of the full moon. Okay, and how do we decide the position of the full moon? It is always with respect to the sun, because it has to be opposite, 180-degree opposite of the sun. In fact, I'm going to mark the full moon position. So look what happens when I click on this. I get this full moon position here. It's always going to be exactly opposite of where the sun is. Okay, so let's start this rotation. So if I stop this like a full moon here, okay, so 1 year has gone, not 1 month, half a month has gone by, and this full moon is here. Now, how do I decide what is the lunar month? I note down where this full moon is occurring. I can extend a line from the earth and I say, it's occurring where? Between, say, Ashwini and Kritika. Okay, so this month could be either a month of Ashwin or month of Kartik. Okay, now whether Ashwin or Kartik, that depends on many other things which we're not going to learn today. Okay, but we get that approximate time period. Now remember, this is not in our times. This is, I'm talking 12,000 BC, 14,000 years ago, the Ramayana times. What I want you to notice is this. Where is my sun right now? Sun is traveling through the area of a Vasanta Rutu, which is a spring season. So yes, the month, full moon here, the month is month of Ashwin or month of a Kartik, but the season is Vasanta Rutu. It's exactly opposite of what is happening in our times, more or less. And why is that? Because remember, the Earth's precession cycle is of 26,000 years. Okay, so half of 26,000 is 13,000, and the Ramayana times is what? It's going back to 14,000 years, which is close to 13,000 years. Therefore, the lunar months and their correspondence with the season is exactly opposite of what we have today. If that confuses you, I'm going to bring you to our times. Okay, literally we will do our year 2021. Okay, that's our year 2021. Let me reset and imagine we had a scenario like this. Okay, so I'm sun and moon at the same point, vernal day of vernal equinox. Let's go here until we get the full moon. We got the full moon. Aditya, can you tell me what would be the name of this lunar month? The full moon is right here. Okay, sun is here. And we decide the name of the lunar month depending on the position of the full moon. So where is the position of the full moon?
Sharad?
No, don't go for season, because season is decided, Aditya, by the position of the sun, not moon.
Right.
So where is my sun? My sun's position is in the Vasanta Rutu.
Vasanta Ritu.
So it is a Vasanta Rutu in our times, right? Right now we are talking 2021. The full moon position is where? You decide by drawing a line from the earth,
correct,
through the moon and go all the way back to the background nakshatra. It's Chitra. Right? So this is a month of Chaitra. This is in fact Chaitra. This is in fact a second month of Chaitra, a second month of the Vasanta Rutu. So how do I know second month of Vasanta Rutu? Vasanta Rutu began here, where my arrow is. This is the first month of Vasanta Rutu, when sun travels through that area. Now sun is traveling from the vernal equinox through this area. When sun reaches here, Vasanta Rutu is over. So right now it's the second month of Vasanta Rutu, and the month happens to be Chaitra. That's exactly what we experience right now. The Chaitra will typically occur at the end of March and a beginning of April month, which is when we celebrate Ram Janma. Okay, so but that is the situation in our times. You see, so I'm going to show you one thing is that right now in our times, the lunar month of Chaitra occurs during the second half of Vasanta Rutu. Okay, but now let us quickly go first to exactly opposite. So let's go to Rama Janma. Now look what has happened. There Chaitra was here. Now where is that Chaitra? Do you notice Chaitra has come here? It has essentially crossed almost through 180 degrees. Why did this change occur? Because of the precession of the Earth's axis, right? So that is what this is happening. So for example, look, that time the previous simulation, I kept the nakshatras constant and I let the Earth's axis move and let the cardinal points move through the nakshatra. It's the same thing, whether sun is moving around the Earth or Earth is moving around the sun. Here we have kept the Earth constant, everything else constant, and we are just moving the nakshatras. Okay, so that's what is that precession of the Earth's axis is. And because that is what is happening, the nakshatra reference nakshatras are moving with respect to these cardinal points. Therefore, the lunar month that corresponds with a specific season also changes, and it goes through the whole rotation in those 26,000 years. Okay, so I'll stop it. So here, for example, 240, this is the birth year of Rama. Okay, what did it do? Okay, reset. Okay, 12240. Okay, so this is the one. So now what has happened is, remember in our times, Aditya ji, when I did 2100 or 2021, the lunar month of Chaitra coincided with the second month of Vasanta Rutu, but that's not going to happen now. Now what happens? For a full moon of Chaitra, it has to, sun's position needs to be exactly opposite, always the case. Now, because Chaitra is here, okay, now I'm going to slow down and stop it. Okay, so in fact, let me go backwards. Okay, so look at this. So this is like a first month this can be month of Falgun or Chaitra in the Rama's time. The Rama's time, his day is Chaitra Shukla Navami. But the point I'm saying is it occurred during the Sharad Rutu. See, look at the position of the sun. It is here. And so the pole star changes, the point of NCP changes, the cardinal points change, and the lunar month of an Indian calendar, it shifts with respect to the season by 1 month every 2000 years. These 4 or 5 things that we just discussed are actually basically the fundamentals of astronomy. In fact, what I'm going to do is this, just one more slide. Okay, what do you see, Aditya ji, right now? I mean, I'm still sharing my screen.
We can see the GeoGebra.
GeoGebra. Okay, hold on. So I just need to share one more slide. Okay, so here, just Earth's axis is inclined with respect to the ecliptic. Hopefully everyone can understand what that is, that Earth's axis is inclined.
We don't see the screen.
Oh, you don't. Thank you. Okay, I need to start sharing. So that's the challenge when you move from one application to another. Okay, so I think you can see the screen now. The point where the Earth axis points to, that is the NCP. Can you see the screen now?
Yes.
Okay. If there is a bright star in the vicinity of NCP, we call that a North Pole star in the Northern Hemisphere. We saw Polaris, we saw Vega. Similarly, in South, we see the Canopus, or also known as Agastya. And this is a cycle of 26,000 years. And this is the precision of Earth's axis. Now we saw the outcomes of it. We already saw why the pole star changes. Okay. Then nakshatras at the cardinal points, they also change. So we saw either the solstices and equinoxes moving, or we can hold them constant and let the nakshatra move. Now this is just in a simulation so that we understand. Okay, but something else, that is the last point. And since lunar month is determined by the position of the full moon, okay, and which full moon position depends on the position of the sun, it's always going to be 180-degree opposite. And since the sun's position with respect to nakshatra at cardinal point with season is changing through this 26,000 years, the lunar month and its correspondence with the season is also going to change. How much it changes? The one lunar month shifts with respect to season by 1 month every 2000 years. Therefore, for example, in case of stars, Polaris was a pole star. Polaris is the pole star in our times, 21st century. It was a pole star 26,000 years ago. It will be again a pole star 26,000 years from now, and it is a pole star today. Thuban was a pole star around 3000 BC. That is another star. Vega, or the Brahma Rashi or Abhijit, was a pole star 12,000 BCE, and it will be again a pole star in around another additional 12,000 years. Remember, the cycle is of approximately 26,000 years. And what I showed you, lunar month of Chaitra during Vasanta, there is a spring season in our times. That's what I showed you. But if you go back to Ramayana times, like 12,000 BCE, same lunar month of Chaitra, but because of the precession, the cardinal points position with respect to nakshatra has changed. 12,000 BC, Ramayana times, the lunar month of Chaitra occurred during the Sharat season. And we see the evidence of that in Valmiki Ramayana. For example, it would be, I will not go back to simulation because it's a bit tricky. Where was the position of Chaitra during Mahabharata times, like 5561 BC? Again, we have to just go and do the simulation. And what we will find is that in the 6th millennium BC, Mahabharata time, Chaitra was the first month of the Shishira season, first month of the winter season. So right now, the lunar month of Chaitra occurs in April in our times, and hot and everything. In the Mahabharata times, that Chaitra, lunar month of Chaitra occurred, which would feel like month of January. Okay, which would feel like would have felt like month of January, how we feel it in Northern Hemisphere. And that all this fun happens because of the precession of Earth's axis. So there are not many phenomena. The phenomenon is one simple, just the Earth's axis making a cycle of 26,000 years. But because of that, we have all this phenomenon. And just then imagine, these are recorded in our ancient narratives around the world. For example, with the pyramid text, they call it, or Egyptian text, they talk about so and so king was there when the earth has gone through this rotation 3 times. And based on that, some people have therefore estimated like 26,000 times 3. And could it be like that 75,000 years ago or something like this? And it might as well be. Similarly, we have a reference to Abhijit becoming a pole star multiple times, like even the time of Swayambhu, Manu, and Prahlad, what is that, Dhruva, and so on, so forth, Uttanapad. And that is how we use that knowledge, use those references to estimate the timing of specific events. Now, what happens is, with the exception of, say, Mahabharata and Ramayana, and there are a few others, the astronomy evidence available for one specific instance is not very rich. So it is not very easy to find a specific timing. The Aditya, the reason I mentioned that is people will immediately come and say, hey, so please tell me the timing of King Harishchandra. I said, well, give me the evidence. No, but it's there. No, it's a lot of evidence. Said, no, you don't read any ancient narratives. That's why you don't know. So we have to have evidence available. Unfortunately, it is true for Ramayana and Mahabharata. It just so happened they are Itihasa texts, so very rich. Ramayana has 600 plus. Many people ask, like, where is that 600 plus evidence? Because they don't know they don't know how to find evidence, and they don't know possibly how to read Valmiki Ramayana. It is there. It is there in my books, of course, but it is there. It is there in my notebooks. Mahabharata 300 plus. So it's a very rich evidence, and therefore that allows us to put it like a jigsaw puzzle. But what I just covered, this may feel overwhelming to people, but I would say there is no shortcut way around. Actually, it's not overwhelming. It's very simple. One can understand it in half a day. One can understand it in like 1 hour's dedication. You have to have some idea of astronomy. You have to have a decent skill set in visualizing. So those people who are into, say, engineering drawings, for example, okay, or imagining building three-dimensional objects, those people who are architects, those people who are in construction, they can look at the engineering drawings and how from there the machines are built or the buildings are built. For them, it's a piece of cake as to what this astronomy foundations are. But some other people may struggle initially, and eventually they will get it. But then we need Shraddha. Okay, so initially you need a Shraddha. You said, well, okay, I will just accept what this person is saying. Let me, it's like scaffolding. When the building is being built, there are these scaffold to hold the wet concrete. But once the concrete dries, you can remove the scaffolding. So the scaffolding acts like a Shraddha. When you are weak, when your intellect is not sharpened, the Shraddha can help you. Eventually, your intellect is sharpened and strong enough that you can learn on your own. So Aditya ji, that's pretty much what I had to say here. You are there?
Yeah. Thank you so much, Nilesh ji. I think it was what a fabulous presentation as usual. One thing which I really like when you show those simulations, because it puts a perspective. A person like me, who is still not well versed with astronomy, also can learn, and other people can also learn. And since you're teaching science, you can experiment it also. And that's why I asked you the softwares which you replied. And I also got used to Skyview to see the stars, also Skyview, and then search from telescope.
Yes, yes. And so see this GeoGebra, the templates that have been created. For example, I can send them to you, like if you want to play around. But let me use this opportunity to generally communicate to our huge audience. I mean, those who watch now, but also watch on YouTube. Many people say, can I get that GeoGebra template? And I say the answer is no. And this has nothing to do with feeling very possessive about it. No, that's not the reason. I mean, that's why I said I can send this to Aditya ji and he can play with it. But it's very easy for me to deal with, say, one individual. If Aditya ji say, why is this happening and this is not matching with some astronomy software, I'll say, well, hold on. This is a simulation, like a demo software. It will not exactly match or, to the precise date. Also, when we want to explain something else, I go back to Amaresh ji, and ask him to make some changes. Or if I notice some errors, like if Rupaji notices some error, we go back to him. And I just don't want many versions of this, like you are in the software industry, like versions of it floating around, and then people coming and saying, look, there is an error here. Well, this is not meant to be a sophisticated software, but this is easy to demonstrate things. And, like in the courses, that's why we are doing it. And that's why we don't want to share those. Only for that reason. And those people who are good, they can build their own. I mean, it's not that difficult to build.
Those doubtful souls who will question this also.
Yeah.
For them, it's a generally accepted practice in the software industry to show simulations for explaining a viewpoint. Because even in the live software, sometimes the software may not work. In the software industry, it is very common that demos always fail. So even the best of the CEOs will show simulations, not the live software demonstrations.
Right. In fact, if we have a time, what I'm going to do, just 5 minutes, can I go on that? Or we are over.
No, please.
Okay.
Go ahead.
So what I want to just quickly show is, for example, why do I show, or someone like Amaresh ji has done a phenomenal job of spending time and generating this very kindly, kindly for us. I mean, we all benefit because of his hard work. But what I'm going to show you is why I would not use the actual very precise and accurate software. Okay, so I'm going to share that screen with you, and we'll show you what it does just in a second here. But see, it's very difficult to see. okay, and just difficult to understand what is happening. So instead of that GeoGebra demo, suppose if I use this software. Now, do you see the screen, Aditya
Yes,
ji? Yeah.
yes, yes, yes.
Okay. So what we are having is this, for example, and you can say it. So this is, remember when it said NCP, I don't know if you remember NCP there. See, that is North Celestial Pole. Okay. That is this white plus sign, if everyone can see it. And that plus sign is next to our current pole star Polaris. Now what happens is, suppose if I give a moment, a step change of 5 years, because remember, we have to go through 26,000 years. I can keep it here and just notice what happens. Okay. So this is like I give a step change of 5 years. It's going to go fast through this. And I'm going to start going in the forward direction for now. Okay. Then I'll do the backward direction. So I say start, and look what is happening. This is that same circle that it creates. Now, as I go in future, the pole point is no longer near Polaris here, but it has gone here, further near this star, Era, and then Aflake, and then this is Al Daramin. So these are some of the Arabic names. So this is where the Earth's axis is pointing to. This where it says plus sign and North Celestial Pole. Now we are going in forward, so it has come to Danube. This is the another star, then Delta here. Then this is here the Abhijit or Vega. And I said, if you remember, that Vega would become a pole star again in around 14,000 CE. So this is what I'm going to show you right now here. So the North NCP is coming close to Vega. So let me say stop here. And if you note down the timing here, this is what, 13,285. I mean, I approximately stopped it. So 14,000, about 14,000 CE. That's when the Abhijit will again become a pole star, because it is the brightest star close to the point of NCP. It doesn't have to be exactly at NCP to be considered a pole star. Sometimes it's possible, like in case of Polaris. And in case of Thuban, this is where you see the Thuban also will be very, very close to that point of NCP. So now what happens is here, look what I need to do. If I don't adjust it, then it's going to go inside. Some portions will not be seen. I may have to move this. People must be wondering, what are these all stars doing? So the GeoGebra demo, this thing doesn't happen, you don't have to move it. And it comes like this. Okay. So yeah, so here, now it's going to complete a circle soon, and it will come back to Polaris here. So this one here, look at this. I'm going to stop it here. So now, which is what year? 22,000 CE, 20,000 years from now, Thuban will be the pole star. Also remember, it was a pole star in around 3000 BCE, so 5,000 years ago. 22,000 plus 5,000 gave you what? 27,000, approximately 26,000 year cycle. Okay. So it was pole star in 3,000 BCE. It will be a pole star 22,000 CE. So it's an approximate cycle of that 26,000 years. I said the same thing about Polaris, which is what? Polaris is a pole star now. It will be a pole star about 26,000 years from today. So again, look at here, 27,000 years from today. So about 25,000 years from today, it will become a pole star again. Okay. So now here, this is how we kind of do it. So 2021 and 80. So this is like our times again. This time what I'll do is I'll go backwards and we can stop after that. So I'm going backwards from Polaris now. Okay. I'm going backwards in time, and very soon it will go into a BC time frame. Okay. Now remember, I said around 3000 BCE, Thuban was the pole star. Right. So that's going to come now here. So this is Thuban here. I stop it. The NCP, the Thuban is close to the NCP. In fact, it's right on the NCP here. Okay, so Thuban will be just moving there. And when was this? 2769 BCE, which is what I said, around 3000 BCE. Let's go backward, okay? And let's go to the Mahabharata times. Aditya, are you enjoying it? so we go to the Mahabharata times now. Look here. Now, there is no bright star, any very bright star in this area, but we have a point around which everything will be rotating. Okay, what we mean by everything rotating, suppose if I turn this to 1 minute, okay, and I create this center. So we are now in the Mahabharata times. Okay, that's the pole star here. There is no pole star, just a pole point. And if I schedule a timing of 1 minute and start it, look what happens. This is what happens to us every day. At every night, if we watch, the point of North Pole is fixed, and all the stars in the area, they appear to go around in a circle and complete one cycle in 24 hours. Okay, so that North Pole is fixed there. Because this is not, now I'm not going back into the precession. I'm just completing one 24-hour day. That's how it is going to go. Now, just so that you know, this is the time when Arundhati was walking ahead of Vasishtha. I will not do that. We have done in a demo, but that can be shown here. That actually the Arundhati is walking ahead of Vasishtha. So my point is, astronomy softwares are cool, but you need to know how to use it. So I will stop here. One quick point I'll mention is this. Look, this star in the modern software is called Arcturus. Okay, its name. But in the Indian astronomy, it is Nakshatra Swati. So what happens is, suppose if I want to take one star here, okay, and I want to give it another name, like an Indian name to it. So for example, I click on the label, and here I may call it whatever the name was, but I'm going to, let's call it Aditya. Okay, Aditya Ji. And I might say include the label pointer, click OK. Aditya Ji, now you are up in the sky there.
Yeah, okay. Mithali will be very upset.
so that star will be there, so that's how actually you can customize your software. My point is, this is phenomenal. This is how I did my research. Of course, I don't want to give you I'll stop sharing. I don't want to give you the wrong impression that it is the astronomy software that does it, because there are other I would say novice researchers who think this is about simulation. No, just like that demonstration, simulation is a simple way to make things visual for people.
Correct.
But actually, whatever I just showed you, you can also do calculations in the Excel spreadsheet. Sometime I will show you the spreadsheets which go for like 10,000 lines. The data that I generate, the data that I crank. Just on Arundhati Vasishtha, I have 10,000 lines of data.
No, very few people will just say that, because they rely on somebody else's hard work.
Yeah.
But anyway, the point is, Mithali will be very upset you did just now. He'll say, oh, he's changing the names, because he explained to Arjun, these are the places of residence of the great souls. Anyway, so thank you so much, Nilesh ji, as usual. Very informative, very learning for me, as well as for other people also who are watching. The people are spellbound. Only one comment I am seeing, and there is 250 comments now in the live show. Spellbound. That's what they are saying.
Oh, very good. I thought they would say, oh my God, it went over my head. No, we have a very sharp crowd here, And frankly, I mean, just the last point I'll make is that in one iteration, one round, if they don't get it, there is no reason to lose heart, saying, oh my God, this is something complicated. It is not. It is not. I mean, I'm a plastic sales guy. My first job that I was known for was a plastic salesperson. And I say, if plastic salesperson can understand astronomy, anyone can. But you need a Shraddha, you need a Tapasya, you need a Sangshay, you need a Jidnyasa. That is important.
And you also need a guru.
And you need a guru. Yes.
Yes. Anyway, so thank you all for watching and listening. And I hope you did take notes. And he also mentioned some softwares in the beginning, and also simulations are only to make a point, and then you can check them, verify them. You can replay this presentation again and again and test it. Our If it is not in the Shastra, we don't discuss it. It's very simple. Otherwise, you create mythology like many mythologists do. And last but not the point, Shastrarth video is coming out, and watch it very carefully, because there's a debate. In debate, there is a one person is a winner. In Shastrarth, Muneya sadhu prishtoham bhavadvi lokam mangal yeh kirta krishna prasam prashno yenatma suprasiddhi. The one who speaks get benefited, the more one who is discussing gets benefited, the one who listens get benefited. So everyone is equally benefiting. It's called
Yes.
Agyat Supriti.
Yes. And quickly, if I can add the coming up thing, because the birth of Krishna's celebration is coming, on the horizon. And with that in mind, maybe few episodes in next few episodes, or at least couple, we will discuss the whole biography as far as we know, based on the evidence, of course, the Shastra evidence, Krishna's biography. So we will do that on Sattology.
And also remember, Devaki Nandan Krishna is not different than Yashoda Nandan Krishna.
Exactly.
Dwarka
Correct.
Krishna is the same as Vrindavan Krishna. It's just like
Yes.
when you were small, you grew up in a different place. And when you're grown up, you're living in some other city. Doesn't mean you changed. Dehino Asminatha Dehi never changes.
Very true.
So thank you all, and namaste.
Namaskar.